Joanna Berzowska. I teach at Concordia University. I've been there for 15 years. My background is both in design and in mathematics, and then so I got a degree in math, a degree in design. This was I started in the 80s, late 80s, to kind of create an education which is now what I teach at Concordia, which we call computation arts, where students learn both a lot of the visual aspects, visual communication, design, working with traditional materials, but also learn to program and build electronics, etc. I went to grad school at the MIT Media Lab, and that's where I got interested in wearables, entering that field through HCI. So how many of you are from HCI, just to get an idea? Okay, so human-computer interaction, I was interested in how humans can interact with not just computers as these boxes, but computation in general. And computers are becoming much smaller. I mentioned this morning that our cars these days, you know, the high-end cars have over 1,000 computers in them. Computers are everywhere, but often we refer to it more as computation. And I became interested in how we can interact with that computation, not just with our hands and eyes and ears, but really with our full bodies. So that's why I became interested in wearables, but specifically in electronic textiles, and wearables in terms of garments that have embedded technologies, computational technologies in them. So the title of my talk today is Quantified Threads, Future Fashion in the Cloud. So it's, you know, hinting at several different topics. One is this idea that the threads that can weave or knit our fabrics are increasingly becoming functional threads, and computation can become embedded in the very fabric of our fabrics. And also this idea of what happens when our textiles, meaning our garments, but also our architectural textiles, this is like a pleather, but actually this is it's a textile that's coated, so this is a textile in fact. If all of our textiles, our blinds, our clothes, our chairs, you know, which have very intimate relationships with our body, actually become computationally enabled, and this idea of the Internet of Things, of all the sensor information, of control, surveillance, etc. What kind of a future are we creating for our children? I have older children, but I also have a newborn baby. And since she was born 8 months ago, I spend a lot of time thinking, you know, when she's 20, which is the age of my older children, what kind of a world is she going to live in? And then I think you guys are the ones who will be designing that world that my child lives in. So I feel a huge responsibility to talk to you about intelligent, sustainable design of wearable technologies. So wearables are a huge, huge topic. On one hand, you might be familiar with all kinds of material research, material science research, electrical engineering type research. This, for example, is a prototype for what's called an electronic tattoo. It's actually a sticker on a flexible stretch substrate that can be applied to your skin. So it's not really a tattoo, it's a sticker. But that actually has, you know, sensors, a wireless antenna, it has a power coil, and it can theoretically process some information about the strain, about your movement, light. There's a photo detector, so how much light there is in the environment, etc. So the world of wearables encompasses everything from one end of the spectrum, kind of research in material science, electrical engineering, to what I call design research, or I called it experiments on this slide, which are projects often funded by corporations, such as this one is funded by Intel and Stratasys. This is a project called the Spider Dress by Anouk Wipprecht, and she was hired by Intel to demonstrate their wearable microcontrollers that they have developed, and they're trying to distribute to practitioners, let's just say, and also working with cutting-edge 3D printing technologies with Autodesk. And We see these examples in the media, you know, material science, design experiments, and they are steps that are being taken to populate this realm of wearables. They're not products. You know, you can't buy one of these spider dresses. You can't buy one of these for your graduate project. They work maybe for 3 minutes. You know, you take a video and then something breaks, but you publish your paper and you know you put out your press release. It goes out into the media and you're good, right? The wearable present, or what we refer to as wearables in the market, actual products, unfortunately are limited to this kind of space, okay? So most of them are really for sports. Most of them are actually for a specific demographic that is masculine. The way they're designed is often geared to the early adopters, which the venture capitalists have determined are guys. So that's why a lot of these, you know, Nike Fuel Band, et cetera, are often like black and with the early adopter in mind being male of a certain age group, interested in fitness mostly and perhaps wellness, but wellness being defined in terms of physical fitness, not really the kind of mindfulness definition of wellness that perhaps is more, well, better in my opinion. More better. So a lot of these devices that are actual products, and it's very important to differentiate between prototypes and products, okay? So the actual products on the market really do focus on fitness and wellness. Most of them are wrist-worn. And in the last few years, there's been a bit of an interest to go more into the fashion domain, you know, so to move beyond just this kind of black polymer, flexible polymer kind of strap. So, you know, the Apple Watch, when it came out, and it's a wearable insofar as it's a computer, or it's, you know, like kind of this, but smaller and worn on your wrist as opposed to handheld, right? They've collaborated with different brands for the wrist straps. For instance, there's an Hermes wristband that's more expensive than the watch itself, right? And then a lot of fashion companies have jumped on that bandwagon to develop their own fashion watches. So and they're not just watches. You know, they have things like this one specifically. I actually put notes here. Scallop, it's called the Scallop, tracks the activities of the users, lets them keep a check on their sleep patterns, the amount of water consumed per day, the appropriate amount of exercise required. I'm not sure how much of that is done through biosensing, how much is through active input into some kind of app, but the idea is that even the high fashion brands are now trying to permeate this market of wearables, but still through these devices. There's this uncomfortable relationship between consumer electronics and fashion. So most of the products that you see, this is a product called June that tracks the amount of UV radiation in your environment and tells you when to apply sunscreen or reapply sunscreen. This is a Fitbit, so the Fitbit being this thing that we saw here. Is this the Fitbit? This is one of the Fitbits, right? Some of them don't have an LCD display, some of them do. Anyway, this is a Fitbit, but it's a collaboration with the designer Tory Burch, so it has, you know, some of the Tory Burch patterning on it. Other wearables such as the Misfit Shine, which also tracks your movement, and through your movement tracking sleep activity, right? Because how do they know if you're sleeping well or not? How do they know? How does the device know?
Or move so much.
Yeah, if you're like tossing and turning, right? So it's the same accelerometer that's being used for your step counting. It's also used to then approximate the quality of your sleep. So even the Misfit Shine, you know, has done collaborations with fashion brands such as Swarovski, right? And the hope is to try to pull these devices into a fashion domain, because the hypothesis is that's how they can sell more. That's how we can have a wider acceptance of these devices. You know, there's been this uncomfortable tension between consumer electronics and fashion, where fashion is seasonal. We don't want to wear the same thing every day. You know, we do wear the same watch every day, except for those of us who have a watch obsession and wear a different one every day. I had a student like that. He had like something like 100 watches. Apparently it's a thing. But to kind of try and pull this consumer electronics market into more of a fashion context by making them more seasonal, maybe customizable, maybe more appealing to different styles, you know, so you can start expressing some of your individuality. Like, I'm somebody who's more into sparkly things, or I'm somebody who's more into minimalist design, etc., etc. But most of them are still on the wrist. There's also, you know, I'm not sure, does anybody know if Ringly is still in the fundraising stage or if they've launched yet?
Yeah, it's launched.
It's launched? Are they shipping?
Yeah.
Have you tried it?
No, I just follow them on Instagram.
Okay. So I just wanted to talk about, you know, the other side of this. So I said there's a lot of research prototypes, then there's some products. Another really interesting part of the space is all the crowdfunding wearables. There was an explosion of really cool wearables projects on various crowdfunding, like Kickstarter, etc., crowdfunding websites. A lot of them have failed, unfortunately, because of the manufacturing constraints. But some of them have been successful, so Ringly, I'm glad, is shipping. Has it been a while?
Well, now they have a bracelet as well.
Yeah. Okay, so they're doing well. That's great. So Ringly is either a watch or a bracelet that ties into your phone. So I guess it has Bluetooth probably in it, and it can pick up on various events that happen on your phone. So when your phone rings, your ring lets you know, or when you get messages, or maybe somebody posts to your Instagram. So instead of getting the more kind of obnoxious alerts that you'd get, the more sort of foreground of awareness alerts you would get on your phone, you get more of these periphery of awareness alerts on your ring or bracelet that you can choose to pay attention to or choose to ignore it, you know, depending on what you're doing.
So does it like vibrate or just light up, or you know what it does?
I thought it changed color, but now I'm looking to you as the expert.
I've actually never seen it in action. I've only seen like still photos.
Yeah, I think it changes color, but that is to be confirmed. So maybe somebody can Google that. I see a couple of people with their laptops open. And, you know, other crowdfunding, projects include the Cuff, which actually tried to develop a full fashion line, right? So bracelets, necklaces, keychains. The application here is around personal protection. So it connects to an alert system. When you're feeling threatened, you can actually activate your jewelry to connect to some kind of security service who can come and help you out when you're in a situation of danger. You know, but the question that I want to ask you today, you know, they're trying to penetrate this fashion market, but is it really fashion, or are these in fact just glorified gadgets, you know, that are trying very, very hard? And my personal take on things is that I don't like calling these wristbands and these other consumer electronics devices wearable in the same way that our garments are wearable. There's something very special about textiles and about our garments. If we use the word wearable, first of all, garments envelop our whole body. They have access to more intimate parts of our bodies. You know, this morning we did a brainstorming exercise around body parts, and we had, you know, not only the penis as a body part, but also, you know, armpits, shoulder blade, elbows, hips, knees. You know, our bodies are much more complex than just our hands and our faces, and our heads, I mean. Most of our interactions with computation happens through our hands and our heads, and there's very good reason for that. Our hands are extremely proficient at manipulating things. They have a lot of sensory capabilities, same for our heads. But there is so much more. And especially when we want to talk about the periphery of awareness, different kinds of sensations, different kinds of interactions, thinking about wellness in a more embodied way, thinking about posture, how does our body communicate, how do our micro movements of our body communicate, how can we develop better knowledge of ourselves by having better awareness of our bodies, etc., etc. There's so much more potential there. A lot of that potential can only be leveraged if we really move towards textiles, okay? Because we don't want to start wearing straps and stickers and, plastic armbands, etc. So the ideal vision of a wearable future, which I'm convinced we're heading towards, is this material revolution in electronic textiles, which will only happen because the materials exist already. It will only happen if we shift our focus to manufacturing and developing manufacturing to support the scale production of these textile products, okay? The reason that I believe it's actually gonna happen, because most of you who are interested in wearables have probably been reading news reports for 10, 15 years that are saying wearables, next year a $20 million market, next year a $20 billion market, next year, $30 billion market. And it's not here yet, right? The reason that I'm convinced it's happening is that companies such as Google are actually jumping in the game. So Google tried to hire me a year ago to, actually it was 2 years ago now, to spearhead their new textile lab. And I didn't move to California, I stayed in Montreal because I like the weather. But they have developed these jacquard textiles with conductive threads woven into the textile, and it's basically like a very simple touchpad. So it has conductive threads in one direction and the other direction, and as you trace your finger on that grid of conductive threads, you can make gestures that can be recognized by the physical interface. And in the case of the Levi's product, I think that's to be used to either control your music or answer your phone, music maps, phone calls. But the idea is, I think it's supposed to be for a commuter, so maybe on your bike, you have your phone in your pocket, the phone rings, and instead of reaching for your phone, you just drag your finger on your sleeve to either answer the call or hang up or send a message, maybe increase the music, lower the music. So this idea is to migrate some of the interaction onto your body instead of the device. So it's a baby step, but they've put a lot of money and a lot of people into developing the future of interaction through textiles. The biggest company that's patenting smart textiles right now, does anybody know or want to guess? So first of all, because they're very aggressive with patents anyway, and they just patent a lot anyway, but it's actually Philips. Philips is not a fashion company. Philips has been patenting smart textile stuff for almost 20 years. They're extremely aggressive, and they are also, what's the word, litigious? Is that's how you say it? Yeah. They sue people who are doing wearables. Actually, I won't tell you because maybe this is not public knowledge, but they sue a lot of people, even friends of mine, who are developing wearables products, okay? So if we have Google on one hand, Philips on the other hand, who are aggressively moving into this space, I think we can safely predict that smart textiles, electronic textiles, and these kinds of wearables that we have all over our bodies will be on the market in the lifetime of my child. And again, you guys will be responsible for creating that future. So I myself have been working with a Montreal company for the last 5 years. The company is called OMsignal, and we've been trying to crack that nut, so to speak, around the manufacturing of electronic textiles. So the first product that we launched that was like a really big deal, it was 2 years ago. It was in collaboration with Ralph Lauren, the Polo Tech shirt. It was launched at the US Open, definitely marketed to a male demographic, very much like high-end sports demographic. Oops. What the shirt is able to do is through knit sensors, so we've actually directly into the shirt, we've knit using silver yarn, we've knit electrodes and other kinds of sensors, so we have a full heart signal, not heart rate, not just a number, but a full ECG, like a medical grade ECG, as well as a breathing signal. That's also not just the breathing rate, but the volume of your breath and the length of inhale and exhale. When you have a full ECG, we can start looking at what's called heart rate variability, which gives us, and that, together with breathing, together with the data we get from an accelerometer, actually gives us a really complex picture of what's happening in your body. Not just whether you're moving or not moving or breathing hard, but whether the hard breathing comes from fear or excitement or anticipation or exhaustion. By looking at how you're breathing and correlating that to your heart signal, we can actually tailor a workout to get the most benefit out of your workout, okay? So that's what this product was really geared towards, is helping you have the best kind of workout. Either push yourself harder, don't push yourself so hard right now, breathe better, you know, try this kind of program on the treadmill, etc., etc.
Can I ask what something like what that shirt would retail for if someone were wanting to buy it?
It's, if you shop at Ralph Lauren, it was the same.
Okay.
So it was over $100,
Yeah.
but if you buy Ralph Lauren sports stuff, it was in the same ballpark. There is, you see here, a box that does Bluetooth and that has some of the extra sensors.
Okay.
And that box was like 100 something extra, but that box can attach to multiple shirts. So the idea is you invest in one box and then can have multiple garments. If we couldn't get the cost down, we wouldn't have a product, okay? So, you know, why am I so excited about textiles? I already gave you some reasons, but there's also other reasons. Textiles themselves are an amazing technology to begin with. So what this shirt does, if we're talking about functionality, in addition to the biometrics and that computational functionality, is it also helps you with moisture management. You know, it's like a wicking, a fabric that takes the moisture away from your body. It also has odor control. It has a special finishing on it that is actually antibacterial. It also, we've designed it to be a compression. It needs to be close to the body, but then we thought, okay, instead of that being a disadvantage, let's make it into a feature, right? It has to be a tight shirt. So we actually worked with experts in compression clothing to design a compression shirt that would help you with your posture and your breathing. So there's areas of compression on the back, so different kinds of knits that naturally make you keep your shoulders back and breathe in a more proficient way, okay? Comfort fit, moisture management, of course it's washable. Again, we wouldn't have a product if it weren't washable. We used industrial testing facilities to test it up to 30 washes with different detergents, you know, like a whole different range of detergents. So basically we wash, dry 5 times, then we would test it 5 times. And you know, with different detergent, this was like, it took a month to do all that testing. So it's guaranteed for up to 30 washes.
So over time, the conductive threads, they will deteriorate though?
Yeah, or maybe, you know, you will stretch it, etc. What was interesting is we actually did studies of how, you know, like maybe you have your favorite shirt that maybe you wear hundreds of times, but a lot of people don't wear things that often. I wasn't part of the team that did these studies, but 30 washes apparently was a very reasonable number for this
Just thinking
time.
for workout stuff too, I feel like if you get more sweaty and more gross than normal clothes.
Well, that's why we have the antibacterial coating
True.
and the moisture wicking. Okay, so textiles are really cool. To make this a real product, we had to be able to manufacture it at scale. in an affordable way and solve quality assurance. So actually it had to be reliable, not much more expensive than a regular shirt, and to be able to actually produce 10,000 in a short time frame. Because the way a lot of wearables that are not consumer electronics, so consumer electronics, we know how to produce consumer electronics. Electronic textiles, the way that most of them are done are in these small prototyping facilities where you can maybe get 100 a week if you're lucky, because there's a lot of manual labor, you know, like insulating things, putting snaps, whatever. They're much more expensive than you'd like them to be. But the biggest real issue really is that you cannot make 10,000 in a week, which is what Ralph Lauren needs to launch a product, you know? Ralph Lauren's not going to launch a product if you tell them, okay, I'll get you 100 units and then maybe another 100 in January, you know? It's just not how it works. So the biggest part of the research was actually how to use existing manufacturing facilities to make this product. So these are commercial, industrial, circular knit machines. We worked with a company in Sri Lanka called MAS, which Ralph Lauren already works with for a lot of their sportswear. They also do a lot of the Lululemon and Nike high-performance sports apparel. They're a very socially sustainable factory, like a really good company actually. I visited them many times and worked with them on the manufacturing of this. And we worked with them to modify their usual ways of working, to integrate the silver threads into these machines. So we had to solve some problems around tensioning, etc., with the machines themselves, but also a lot of problems you wouldn't expect around sourcing materials, quality assurance, issues around tolerances. It's kind of the same, but completely different to make a smart textile versus a non-smart textiles. And I usually put quotes around the word smart, but I'm going to put my fingers away for this, because of course that word is really silly. But you know what I mean. The idea is, we were able to do it for the shirt. It took much longer than we thought, I'll be honest, because we came up against problems that nobody had anticipated, and through a wonderful collaboration between Ralph Lauren, OMsignal, and MAS, we were able to finally solve them all and actually ship the large number of units at a low cost with a very low failure rate. Once this becomes a little bit more entrenched and more companies, join in this effort, the idea is that either biometric or other kinds of computational textiles will become widespread, and it will allow us to have much deeper knowledge, not just of individuals, but also of populations, of crowds. And I mentioned this morning, that the utopic scenario around this is that it will help us shape policy around wellness, around health, and help, corporations and governments and different organizations have more insight into the health of a population, help people lead better lives, etc. Of course, the flip side, the more dystopic scenarios, are that Google will own all that information, and I don't know what they do, Google knows where I am right now because I have Google Maps installed. Google knows what I just searched for. I don't know what they really do with that, but there is a level of discomfort, right? That one corporation actually knows more about me than my husband, or my husband and my mom and my children all combined, right? And once Google has access also to my fingerprints, my sweat, other biosignals, what does that mean? What kinds of legal, although legislation is always far behind, but what kinds of legal or social, ethical questions do we need to be thinking about as designers, right? And I mentioned this morning, one of you asked, actually I don't think she's here, asked about this, and I think there's a big need for activism in this space, there's a big need for critical design, and also for designers who kind of understand all of the implications of these technologies. Okay, so at the same time, since this lecture series is about the user, I think it's extremely important that we think beyond the quantified. So what I've talked about so far really fits into the realm of the quantified self. It's this movement, this based on a desire for better understanding through biometrics. So am I moving enough? Am I eating enough? Or too much? Am I running? How is my sleep? How is my health? How can I better myself? But based on quantifiable information, often biometric information. Both in our garments and just in our social lives, there's so much more than that, right? So I think it's also extremely important to move beyond this quantified approach when we talk about wearables, and to create beautiful, pleasurable, ironic wearables that can actually enhance what I'm calling your human experience. Maybe to create new social and cultural experiences, and find new ways to extend the meaning of what we wear on our bodies. You know, most people, when I say that, they maybe think automatically of social media. Sure, that's one aspect of it. But, you know, a lot of us wear clothes for a variety of reasons, and what's this? Oh yeah, okay. And even if we look at this really old Freudian psychologist, you know, it's a quote that's very relevant still today, that clothing performs a range of social and cultural function, individual, occupational, and sexual differentiation, social status, etc., etc., etc. So how can we play with that, right? So on one hand, I keep hitting the wrong button. So on one hand, we have the quantified self, so the OMsignal shirt. We also now have this bra that we developed finally after 5 years. The board of directors allowed us to develop a product for women, because they were not the early adopters, they are the late adopters, I guess. But that also focuses on sports, performance. The long-term vision for OMsignal, however, is a little bit broader. It's still quantifiable, but it's a little bit broader. It's about wellness. We have this video on YouTube. If any of you are interested, you can go to the OMsignal YouTube channel. There's tons of videos. So this one is specifically about the long-term version of long-term vision for OMsignal. And the idea is, you know, that this whole family is wearing OMsignal undergarments. So here's a wife, she's pregnant, she's, I guess, on medical leave before she gives birth, so she's going for yoga to relax. Her husband is still working, he's at the office, and his shirt determines that he's really stressed, so it automatically sends a signal to the wife that says, John seems very stressed. She sends him a little, like, I love you message, remember to breathe, you'll be great, I love you. You know, the idea is he wouldn't necessarily have reached out to her. You know, so you can see these like little, it's very like stereotypical gender roles, of course, but you can imagine these small improvements to our wellness, right? When I'm really stressed, and I should reach out to my husband, but sometimes I don't, and I sit there fuming. But if he called me at that time, that would be wonderful, right? So she's working out, her shirt actually tells her how well she's breathing, how well her workout is. Oh, but look, there's another alert. Her dad's heart rate is really high. So then they rush to the hospital. Her dad's in the hospital. Thankfully, he's okay. So they're sitting there, everything is sorted out, and then through her shirt, she actually shares her heartbeat, the heartbeat of her baby with her father. You know, so this is still based on quantifiable data, but it gives you a little bit more of this kind of human aspect to the potential impact of these technologies, about communication, closeness, and having the sorts of connections between each other that are more meaningful than maybe Facebook statuses, which are also meaningful, but you know. So the video is on YouTube. I won't play it now. I already told you the ending. The father lives. He survives. He doesn't die. So I'm going to take a bit of a step to the side, though, and talk about, so I talked about identity as a quantifiable thing. Maybe I'm stretching it a little bit, but that's what the OMsignal work is about. What I do in my research lab at Concordia, my research lab is housed within the fine arts. So what I do there with my students is really explore much more the poetic, the political, and the questionable aspects of these technologies, okay? So my research lab is called XS Labs, and even XS, it's a bit of a pun because it's XS, so it stands for extra soft, it's soft technologies, but it's also, a bit of a play on words, excess. Do we really need all these technologies? I'm obviously working in this space, so I think yes, but we need to be very nuanced and complex in our thinking when we're developing them. So I do a lot of these speculative designs or even design explorations. For instance, one of the questions I ask is, what does it mean for our garments to have a memory? What does it mean to have, and I call this set of projects memory-rich garments. What does it mean for our garments to have memory? And of course, they already have a memory, right? Like my sweat is in this shirt, maybe a few hairs, my dog's hairs, my skin cells, the coffee I spilled earlier. My shirt already has a memory, but with sensors, with biometrics, with active materials, it will have even more of a memory. So for example, we did a whole exploration around history of touch. What if your clothes remember how they were touched? So we often start out by doing sketches. I have this really large textile printer, so we're able to just quickly print out cotton, like a cheap material, and I print out the pattern for the dress, so the dress pattern, as well as the graphical patterns. And then we just quickly sew them. It takes like 10 minutes to actually have these, I call them sketches. So, these are two sketches of garments that have a memory of touch, and the narratives are completely different, What kind of story does this dress tell? This dress is saying, the person who's wearing me is kind of self-conscious, she's saying, am I too fat? Does this dress make me look good? Do I look okay? She's touching herself and perhaps is not very self-assured. The story this dress tells is completely different. First of all, it implies the presence of another body, because these positions are impossible with your own hands. And of course, the history of touch is in very intimate areas, right? So again, if we look at this, the obvious question is, okay, well, do I want my dress to show that I'm really insecure? Do I want my dress to show when I was actually cheating on my boyfriend? Oh, but maybe I actually do want my dress to have that if somebody molests me on the subway, to actually have that record, so then when I go and file a claim for sexual assault, I have proof. So we can right away start thinking about these complex scenarios. What does it mean for our garments to have memory? And there's, again, utopic or good things and bad things. There's potentially applications that will improve our quality of life, but also that can be misused, that can be used for surveillance and intrusive sorts of things, as well as for personal empowerment. A lot of technologies walk that fine line between empowerment and disempowerment, right? Right? How do we find the right balance? So we start out with sketches, we develop a list of questions, okay? And then we start experimenting with materials. So here, this is a thermochromic ink. You can't see it so well, but basically, then I make the same set of dresses, but using thermochromic. So if somebody touches you, the color changes. And here I use the metaphor of camouflage, so that when somebody touches you and warms up that piece of fabric, the camouflage disappears. So it's this metaphor that suddenly you become revealed. Your camouflage disappears and you're nude in front of others. Then we developed different electronic approaches to encoding memory on the body. So this is a very old project, it's 10 years old. And we used different embroidery and brocade techniques to embroider essentially this analog circuit with different transistors and LEDs and capacitors. And this is a touch sensor just made out of silver organza, so it's a very crafts-based approach. And the idea is if somebody touches you, the intensity and the length of the touch is then reflected in the intensity and the length of the illumination of the LEDs. So if somebody like really gropes you and touches you for a long time, they glow for a long time. If somebody just touches you quickly, the glow fades very quickly. Again, same questions, you know, it could be used, hey, fun for a rave, for a party, a safety kind of thing. If somebody touches me and I don't want them to touch me, the thing blinks, you know, and suddenly people will come and help me. Or maybe, like, again, same kind of story, what if I'm being touched and I don't want Lois to know, you know, and then here I am and my skirt is glowing and Lois will be like, Joey, what have you been doing? So these technologies are very needy for deeper discourse, okay? If you know what I mean. I also work a lot with different kinds of materials, right, for display. So often when we think of wearables, a lot of them have sensors, biometric sensors, maybe environmental sensors, and then they either have like LEDs that blink, or maybe a vibration, or maybe a LCD panel or something like that. So I've been really interested in other kinds of displays. So I work with shape memory alloys, for instance. So this is a flower that just opens and closes. And I have a video of something else in a second, so I'll just go to that. So these were like first prototypes with nitinol. So of this dress with just flowers that open and close, and this other dress with the hemline that goes up and down. But I work with nitinol instead of robotics because it's a very organic movement, you know? I'll show you an example. Then I developed this whole line of dresses called the Scorpions dresses. And here you'll see the quality of the movement. This is from a prototype for one of the dresses. It's very organic, almost like an animal or plant-like, you know? It's, that's why I love working with different materials, different active materials, rather than robotics and motors, because the quality of movement is much closer to what we think of when we think of the body and the way the body moves.
So that's nitinol?
Yeah.
So what is that, like an electrical conductive thing?
Yeah, it conducts electricity. It's a shape memory alloy that you can program to have different shapes at different temperatures. So we programmed it to contract and blah, blah, blah. And then we use resistive heating to control the temperature. So actually using pulse width modulation and passing electricity through the nitinol itself, we can get it to certain temperatures that activate the different physical states.
So how do you regulate that with an Arduino or something?
No, we developed all of our own electronics. I'm
Okay.
sure you can do it with an Arduino, but we use pulse width modulation so it doesn't overheat and burn. So you just send bursts of energy instead of like just straight on current. And so that prototype was used for this dress, for instance. So this is called the Enleon dress. And again, you know, these are like museum pieces. We show them in museums and galleries all over the world. So they have, and this project was published at ISWIC, which is an IEEE conference, but also shown in like art museums. So I also like to walk that line of art design and engineering, right? And to try and be provocative in both spaces. Yeah, so here the idea is that these things lift and they provide these perforations through the body. I ended up lining them with mirrors because it was a bit too pornographic in the end to have these. You know, I wanted to kind of ask questions about private and public and what's revealed, what's inside, what's outside. But then when we actually put it on, it was just kind of like a peep show kind of pornographic thing. So I ended up lining those perforations with a mirrored surface so you could still have these conversations about privacy, public space, how garments help us to control our public appearance, et cetera, without having that porn. I mean, I have nothing against a controlled use of pornography, but that wasn't the point of this project. I'm also, really critical of our increasing reliance on batteries, Batteries are extremely harmful to the environment. They're one of these technologies that's actually not improving over time as fast as other parts of our electronics. They're just as harmful as they were 10 years ago. They're not much smaller than they were 10 years ago. Maybe some of them are even like lithium polymer rechargeables are actually dangerous. Phones are exploding in airplanes, etc., right? So battery technology is actually extremely problematic. So I've done a range of projects around human-generated power. This is a project called Captain Electric and Battery Boy. And the idea is to leverage the discomfort of fashion to create electrical energy. So the theoretical context here is that high fashion is often based around discomfort, high heels, corsets. This is both for men and women over history across different cultures, that high fashion, or just fashion in general, has a relationship with discomfort as a way to elevate itself, right? So how can we use discomfort to create power? So there were 3 dresses: itchy, sticky, and stiff. And it's fairly self-explanatory. So this one is itchy, and it has all these really itchy collars, and when you scratch yourself, when you move them, you're actually powering the dress. So the very discomfort of the garment creates the energy. Yeah, so my poor students, I forced them to demo. So it's already 12:51. I'm going to wrap up in the next few minutes, which will leave us some time for questions. I just wanted to say that in order to enable this revolution in textiles, which I'm hoping will be more complex than just fitness trackers, and that's why I'm doing the research in fine arts, we also still need to pursue a lot of research in material development and manufacturing. So I'm working with a scientist called Maxime Succour-Bogatti in Montreal to actually develop the next generation of functional fibers. So we've done a lot of work in terms of photonic band gap fibers. We've developed capacitive fibers. So these are kind of what I mentioned at the beginning. These are prototypes, okay? This is not a product. We made a meter of it. It cost us $50,000. We published the articles. It might be a product, by the time my daughter is a teenager. We've developed these batteries that are actually polymer-based flexible batteries. They're like these little power strip kind of things that we can weave, okay, etc., etc. But again, this is like materials research. At the same time, I'm working with designers, with fashion designers, to also question, what does fashion design mean? Right now, a lot of these wearables, a lot of interactivity is based around a very simplistic notion of you have your object and you push a button, something happens, or there's a sensor thing, something happens. But in fact, once we move into materiality and programmable materiality, the whole thing can deform, right? It's not just like, oh, this and the flower opens, but everything can shift. Again, this isn't 20 years, etc. In your careers, okay? You have to think in the long future as well as the short-term future. So I've been working with designers to develop approaches to design that are much more based around theories of performance and time-based design for the body. So I'll leave it at that because it's a whole topic in itself, but I think it's very important. So I'm just going to finish by mentioning a couple of things about manufacturing. Why aren't there hundreds of awesome wearables in the shops, okay? One huge problem is that we're still stuck in this consumer electronics world, both in terms of how VCs fund startups. It's very hard to get VC venture capital funding for a textile product. It's really easy to get VC funding for an iPhone app. It's very easy to get VC funding for a little electronic thing. So there's the funding, there's the manufacturing, and there's also still the consumer perception that wearables should be like these consumer electronics, okay? So we're still kind of stuck in that modality. At the same time, there's this disconnect between the hype, you know, the Lady Gaga costumes, the Katy Perry Twitter dresses, the whatever, the spider dress, like we see, like, oh, this is what wearables should be, these insane costumes, and what people actually want to buy. So I think that's a bit of an issue as well. And actually fabricating smart textiles is still really expensive and complex. So even though we got the cost of the Ralph Lauren shirt down to a very reasonable price, to get there it took us much longer than it should have. So the R&D process was very expensive, even though the shirt itself was very cheap given what it is at the end, okay? So there's still a lot of money that needs to go into R&D for manufacturing. Manufacturing will only become real if we base it on what exists, start integrating new kinds of materials, start layering other components. So in this big field of additive manufacturing, adding different kinds of lamination, fusing, coatings, ultrasonic welding, bonding, printing, etc. Because once we knit these sensors, we need to insulate them somewhat, we need to laminate, connect, etc. We need to put more work into developing future fibers and collaborations between textile engineers and material scientists. So chemistry, material science, new functional materials, all of this is very important. And just to conclude, we have to really move beyond this vision of wearables when we're designing. So that's again my call to the students in the room, and the teachers too, I guess, is if you're working on wearables, start asking the more difficult questions. You know, how will this affect the individual? How will this affect culture, society, our relationships, interpersonal relationships, emotional states, etc., etc., instead of just saying, what does it do and does it blink, you know, when I get an email. So it's a big project, but it's an important one. So thank you very much for your attention.